In today's lab, we're going to take a look at two questions, and both of these questions are going to revolve around friction. They're going to revolve around the force of friction. The first question is, what is the effect of the normal force on the force of friction That's question number one. And the second question is, what is the effect of surface type on the force of friction? In order to get some data so that we can answer these questions, we have to do a little bit of an explanation of how this is going to work. So for our apparatus, we're going to have things run on a table. So this is going to represent our table. And on that table, we're going to place a piece of wood. So there is a small piece of wood right here. And attached to that wood, there'll be a little hook. So there's kind of a hook right there. And then attached to that hook, we can then have our spring scale. And of course, you have used our spring scale in the past, and so you know that we can measure forces using our spring scale. And then the thing that we can vary here is we can add various amounts of mass to our piece of wood. And by pulling here on our spring scale, we're going to be able to create various applied forces. So let's take a look at the forces that are going to be involved in our experiment today. So let's let this represent the piece of wood. And here's the hook to which we are going to attach the spring scale. And as the wood is sitting here, of course, it's sitting on our table. There's the top of our table. As it's sitting here on our table, we know that there's the force of gravity pulling down on our wood, including all the mass that we might place on top of our wood. But of course, it's not crashing to the floor because the table is pushing back. It's creating the force normal on our piece of wood. And those two forces, the force of gravity and the normal force, are going to be equal in magnitude. So the force of gravity and the force normal are going to be equal in terms of their magnitude. They have different directions. The force of gravity is pulling down and the normal force is pushing up, but their size should be the same. And so we can determine the magnitude of the normal force by calculating force due to gravity. And of course, we know that force due to gravity is going to be our mass times little g. So that's going to be pretty easy to figure out. All we're going to need to do is know the mass of our wood plus any other mass that we put on top of our wood there. But there are going to be some other forces that are acting on our piece of wood. So we're going to have our spring scale, and we're going to take our spring scale. So let's kind of have this represent our spring scale. And here's the hook on our spring scale. And there it is. We're going to pull with our spring scale and try to get our wood to move across the table. So we're going to apply a force. We'll call it FA for force applied in that direction. But it's not going to be so easy to pull that piece of wood because there's going to be some resistance of our table. Or we're going to also place it on another surface, a kind of a rough piece of plastic, and that's going to resist the pull. So you can imagine that if we did this on an ice skating rink, which I'm not going to find in the middle of the summer in St. Louis, that the resistance, that friction is going to be less than if I were to do it on a table. And the table is probably going to be less than if I were to do it on something really sticky or really rough, like a piece of sandpaper. So we're going to have that force applied, how far we pull on it, and then we're going to have the force in the opposite direction, the resistance to that force applied, which is what we're going to call our force of friction. And the magnitude of those two forces, once we kind of get it up to speed and it's just moving at a constant speed, the force that we apply when we pull with our spring scale should be equal in magnitude to the force of friction. So our force applied should equal to the force of friction, at least in magnitude. So it should be fairly easy to get at what our force of friction is because we can measure with our spring scale. So our first question, recall, let me bring back here. Our first question was, what is the effect of the normal force on the force of friction? So from our apparatus, we're going to be able to vary the normal force by adding various masses. So these would be masses that I add to my wood here. And as I increase the mass, I'm going to increase my force of gravity, which means I'm going to increase my normal force. And then we can measure the force of friction by how hard it is to pull, and we'll use our spring scale to measure how hard it is to pull. For our second question, what is the effect of surface type on the force of friction? We're going to run our entire experiment twice. Our two surfaces are going to be, number one, the table, and number two, we're going to use a sheet of plastic. So those are going to be our two surface types, and we can then compare what happens to the force of friction on a smooth surface versus a little bit tackier surface, which would be our plastic. So just before we start to gather our data then, what is our data table going to look like? So if you turn to this page, which at least right now is page 151, you're going to see the data table at the bottom of the page. And so, of course, you want to start with your title of your data table. So let's take a look at the effect of F normal and surface type on, we'll just go FF, on the force of friction. So you've got two sides to our data table. The left side is where we're going to record our information for the tabletop, And the second side, the right side, is going to be where we record our information for the ridged plastic. So what we're going to do is we're going to vary the mass, which is going to allow us to calculate. So this we will physically do. Then we're going to be able to calculate Fn by using our mass times 9.8 newtons per kilogram. And that's going to equal our force normal. So we can record that here in this magnitude. And for our force of friction in this column right here, we're going to read the force of friction from our spring scale, because the force of friction's magnitude will be equal to the force applied that we pull with our spring scale. And now we're ready to gather our data.